Good morning, students. We are going for a quick recap of the chapter. Then, in science, we have studied the first chapter, that is matter in our surroundings. Before starting our chapter, what is science? Science is the study of nature and natural processes. Natural processes occurred in the universe is known are the natural processes like eruption of volcanoes, all the movement, flowing of water, that is breaking of any substance, formation of fruits, etc. The branches of science are generally three. The first is physics, chemistry, and bio. So starting with the physics, physics is the branch of science in which we study about the motion and motion related processes like moving of body, that is a motion. All the terms are included in the motion in which we are going to take about the motion. For example, movement of light, movement of electricity, all are the examples of motion. Next, we are going for the second definition, that is about the biology. It is defined as the branch of science in which we study about the living beings and their processes, that is the life processes. Example, respiration, we human beings respire, digestion, that is conversion of food into energy, and many more processes, growing of a body, reproduction, all are included in the biology. Next we are coming to that is about the defined chemistry. Chemistry is the branch of science in which we study about the structure, composition, properties and reactions of matter. Structure is the three-dimensional, how it looks, properties, how it behaves, composition, how it forms, and the reactions are the changes occurred in matter. So next is the defined matter. Matter is anything which occupies space and has mass and can be felt by one or more our senses, one or more our five senses. The five senses are sight, देखना, smell, सूंघना, taste, चखना, touch, किसी को भी touch करना, and listen, सुनना. Example, pen, pencil, table, scale, building, rocks, all are the examples of matter. Next we are coming to the what is the nature of matter. Matter is made up of very small substances known as particles. Each matter is made up of very small particles. For example, chalk powder appears chalk appears to a single, but when it broken it contains large number of tiny particles. So these tiny particles are known as atoms. So define atom, the simplest, smallest substance which cannot be further divided is known as atom. For example, a small raindrop contains many crores of particles, many crore particles in it. A small raindrop contains many crores particles in it. Next we are coming to the what are the properties of matter. The particles of matter are very small. I am giving you a discussion about the raindrop, that a drop of rain, one drop of water contains crores of particles in it. Hence it shows that the particles of matter are very small. The particles of matter are made up of very small substances. This can also be shown by using an example, that if you put an ink, blue colored ink, in a water tub, the whole solutions get blue colored. This one drop of ink spreads into thousands, many lakhs of particles dissociated in the tub. Take one glass of water from the tub, that is the blue colored solution. Put this one glass water in another tub of water, then the solution gets some light blue colored. Further, when more one glass solution is taken into new tub, then the further solution gets weak in color. This shows that as we add water into the substance, the solution gets light colored. That means the particles gets more dispersed, which shows that particles of matter are very small. Second property of matter is they have space in between them. To check this activity, we can determine using a glass of water. Half glass of water is taken and put a mark on it. Now add some amount of sugar to it and dissolve it. After dissolving sugar, you will see that the volume of sugar will not increase. Again, some more sugar is to be dissolved. Again, the water does not increase in volume. This shows that the water contains some space in between them, in which the sugar particles gets dissolved in it. This shows that the particles of matter have space in between them. Next is the particles are constantly moving. The particles are constantly moving, shown by the Brownian movement. Brownian movement is the discovered by Robert Brown, scientist, which shows that the pollen grains are constantly moving in water when seen through microscope. Similarly, you can also see that when projector light is coming, then you see that there is regular movement of small particles in their light. This shows that the particles are constantly moving. This can also be shown by using an example of the incense stick, agarbatti. When you burn the incense stick in one corner or you spray perfume in one corner, its fragrance can be felt in the second corner, in the another corner. This can also be due to the movement of particles. As the particles constantly move, then the fragrance will also move. If the fan is on, if we switch on the fan, then the particles will fastly move, because the air helps to increase the speed of movement of particles. Next is the particles of matter have force of attraction in between them. This is the very simple, like it's easy to break down the chalk, but it is difficult to break down the iron nail. This shows that different particles have different force of attraction in between them. So this is about the properties of matter. Next we are coming to the states of matter. There are 5 states of matter, out of which 3 are very important and very general, that are the solid state, liquid state, gaseous state, plasma, and Bose-Einstein condensate. Firstly, we discuss about the solid state. Solid state is defined as the substances which are having fixed shape and fixed volume. They are also known as rigid. They are also called rigid, ठोस कहते हैं इन्हें. They have strong force of attraction between them and the particles are very close to each other. The particles can't move. They show only vibration at their position. They can't show diffusion. Solids are incompressible. Solids are having a very high density. The interparticle space is very less. So these are the properties of solid state. Example is ice, pen, sponge, rubber band, stone, salt, etc. Next is the liquid state. Those substances having fixed volume but not having fixed shape. They can flow easily and also known as fluids. They have less force of attraction than solids and particles are not close as that of solids. They have less density than solids, they show small diffusion and they are also incompressible in nature. The example is water, ethanol, ink, honey. Okay, all these are the examples of liquids. Next is the gaseous state. Those substances which neither have fixed shape nor fixed volume. they take the shape of container, they fill the container completely, they flow very easily, they are having very weak force of attractions between them, and the particles are very far away from each other. They shows diffusion and they are highly compressible in nature. Their density is very weak, they have very weak density. After then we come to that is the plasma and Bose-Einstein condensate. The plasma is the state which is having super cold state, which is known as a super cold, that is at very low temperatures, and Bose-Einstein condensate is the state present at very high temperature. Next we are coming for the interconversions of states. How we can convert solid into liquid, liquid into gas, gas into solid. Again, these are all the examples of interconversions. Interconversion can be done by change in temperature and change in pressure. Change in temperature consists of very first important step is known as freezing. It is a process of converting a liquid into solid state on decreasing temperature. When we decrease the temperature, the kinetic energy decreases, the molecules comes closer with each other, known as freezing. Example, water to ice. Next is the freezing point. The temperature at which a liquid converts into solid state is known as freezing point. At atmospheric pressure, you can say. The freezing point of water is 0 degrees Celsius. Next we are coming to the reverse of freezing, that is known as melting. It is a process of converting a solid into liquid state on increasing the temperature. Because on heating a solid, the particles require energy to overcome the inter-attractive forces and they starts moving, known as the melting. Example, ice to water. Next is now what is melting point. The temperature at which a solid converts into liquid state at atmospheric pressure is known as melting point. For example, melting point measures the strength of the interparticle forces. The melting point of ice is 0 degrees Celsius. Remember, the freezing point of water is 0 degrees Celsius and melting point of ice is also 0 degrees Celsius. Next we are coming to the state that is the boiling. It is a process of converting a liquid into gaseous state on increasing temperature. When we increase more temperature, the particles are fastly moving, kinetic energy increases and particles start to move away from the container, then the process known as boiling will occur. The waters converts into vapors is known as vaporization. The reverse of boiling is known as the condensation. It is the process of converting a gas into liquid state on decreasing temperature. It is the reverse of boiling. So next we come to the condensation point, the temperature at which a liquid state a gaseous state converts into liquid state at atmospheric pressure is known as condensation point. It is reverse of boiling point. So if you have to discuss about the boiling point and condensation point, it is same. The condensation point of vapors is also 100 degrees Celsius. Next we come to the change in temperature, very important process, that is known as the sublimation. It is a process of direct change of state from solid to gas on heating and gas to solid on cooling. So example is naphthalene balls you can see, that is the white colored small balls, camphor, that is the kapoor, iodine, vapors are there, benzoic acid, ammonium chloride, all are the examples of sublimation. They can show sublimation process in which the solid is directly converts into gaseous state. This is the complete chart. You can make it. Here I am showing you that the gaseous particles are having away from each other, but in solids they are having strong bonding with each other, but in liquids they have less bonding. So this is the interconversion. Liquid to solid is freezing, solid to liquid is melting. Liquid to gas is evaporation or vaporization, vapors to liquid is condensation. Both process can be written sublimation, or solid to gas is sublimation and reverse is deposition. Next we are coming to the change in pressure. When we increase the pressure, solids and liquids are having no effect. But when we apply pressure to gases in a cylinder, the particles comes closer and the gases converts into liquid state. Example, that is the LPG, that is known as the liquefied petroleum gas. CNG, compressed natural gas. Liquid oxygen is also used for the hospitals, and liquid is converted to carry easily. The SI unit of pressure is Pascal, and to convert it, 1 atmosphere is equal to 101,325 Pascal. Next is about the temperature interconversions. There are three temperature scales. SI unit is in Kelvin and common units are Celsius and Fahrenheit. To convert Kelvin into degree Celsius, Kelvin is equal to degree Celsius plus 273, and to convert Fahrenheit into Celsius, that is Fahrenheit is equal to 9/5 degree Celsius plus 32. So there are some examples which we have done earlier. Try to solve it. Next is about the evaporation. The phenomena of change of liquid into vapors at any temperature below its boiling point is known as evaporation. The conversion of liquid into vapors below its boiling point is known as the evaporation. Example, drying of wet clothes. The water escapes out in the pan when left for many days. These all are examples of evaporation, and it can be occurs below boiling point. Next is the factors affecting evaporation. What are the factors affecting evaporation? The first factor is temperature. As the temperature increases, the evaporation increases because particles start moving fastly. As the wind speed increases, also evaporation increases. Again, the particles start moving fastly, and hence the evaporation increases. As the surface area increases, evaporation increases because it is easy to remove the water vapors from its surface because the surface area is small. Next is about the humidity. As humidity increases, evaporation decreases. This is the only factor in which evaporation decreases. Also, a liquid having weak interparticle force is having high rate of evaporation. For example, acetone, petrol, they can boil at near about 78 degrees Celsius. They can form vapors even by touching our hands. That is the volatile liquids. Those liquids whose vapors form faster are known as the volatile liquids. Next we are coming to the cooling caused by evaporation. Water kept in an earthen pot matka becomes cold during summer. We sprinkle water on the roof or on open courtyard during summer. We prefer to wear cotton clothes in summer. Desert cooler is used in summer because of evaporation. Next we come to the important topic named as the diffusion. Diffusion, it is a process of intermixing of different substances on their own without the help of external agency. It is the mixing of different substances on their own without applying external force. Diffusion is of three types: diffusion in solids, liquids and gas. Diffusion in solids is very slow because they have very strong force of attractions. It is very difficult to move the particles. Example, but in case of liquids, solids and liquids, it can show. For example, mixing of potassium permanganate solid crystals to water shows the purple colored solution. Next is about the diffusion in liquids. Diffusion in liquids is faster than that of solids because they have less force of attraction than solids. For example, a drop of ink is put into the water, then the whole solution becomes colored within few seconds. This shows the diffusion in liquids. Next is the diffusion in gases is very fast because the particles in gases are having very weak forces and they are moving very fastly. Example, diffusion of bromine vapors in jar. You can see the befores in the starting time. In the starting time, what happens? Only one jar of bromine vapors is there, and I have put an empty inverted jar on it. After some time, we see that both two jars becomes brown color due to diffusion of gases. Next we come to the after diffusion in gases, that is the next important topic is the latent heat. It is the amount of heat required to convert a solid into liquid state or a liquid into vapor state without change in temperature. It is the amount of heat to convert solid into liquid or liquid into vapors without change in its temperature is known as the latent heat. It is of two types, latent heat of fusion and latent heat of vaporization. Latent heat of fusion, the amount of heat required to convert 1 kilogram of a solid into liquid state at the atmospheric pressure is known as, at melting point is known as latent heat of fusion. For example, I have taken ice in the beaker, I have put a thermometer in it, and as I start seeing that in the first the temperature is 0 degrees Celsius, the ice starts melting, the water is 0 degrees Celsius. But as we are more applying the heat, the temperature of the beaker remains 0 degrees Celsius, but the ice starts converting into water. This extra heat which is to be supplied is known as the latent heat of fusion. Next is the latent heat of vaporization. It is the amount of heat energy required to convert 1 kilogram of liquid into vapors at the atmospheric pressure. At its boiling point is known as latent heat of vaporization. The latent heat of vaporization of water is 2259 kilojoule per kilogram. What are the conclusions? Ice shows more cooling than water and steam is more powerful than boiling water. So this is all about the revision of chapter first, that is matter in our surroundings. If any doubts, you can contact me. Try to solve the NCERT questions itself and try to solve the S. Chand questions. Lakmeer Singh book you have. Try to solve the questions given in the book, and if any problem, you can contact me. Thanks and have a nice day.